Okay, thank you, Mizna, for the warm welcome. First of all, thank you so much for offering me and inviting me to present my research work at this platform. My name is Danesh Gul Farid, and I'm pursuing my PhD in Energy Science and Engineering at the University of Naples, Parthenope in Italy. And my professors are Professor Fabio De Felice and Professor Antonella Petrillo. And I'm here to present my research work on investigation of best available technique for energy and environmental performance in textile industry, combined SWOT and ARAS-G approach. The framework of this research is to rank the best available techniques that I will be explaining later in this presentation, using the multiple criteria decision-making approach of ARAS-G approach, that is the extended version of the Gray numbers famous Gray logic, and so that the scores can be assigned to all these best available techniques so that they can be implemented in the textile industry to make the textile industry more sustainable and to improve the energy and environmental performance of this industry. So these are my contents. First, I would like to start like what is the motivation behind to select this research area, and then I would like to tell like what is the status of the textile industry in context of the sustainability. Then I will share like what are the best available techniques, and later I will share like what are the results and discussions of this my research, and then I will conclude with the conclusion. Okay, so in the modern society we are living today, we face many problems, and one of the major problem is the climate change. Climate change, which is a long-term shift in global or regional climate patterns, has become a global sustainability challenge now. Why it has become a global sustainability challenge? Because we humans roughly emit 52 billion tons of greenhouse gas emissions each year. And because of this, Earth's temperature has risen 1.1 degrees Celsius since pre-industrial times. So this figure of 52 billion tons of greenhouse gas emission is the total value of in terms of the carbon dioxide emission equivalency. So that also includes the other gases, that includes the methane and SOx and NOx and other gases. But if we just talk about the carbon dioxide emissions in the environment, just look at this graph. And here you can see like the graph has been increasing year by year. The only slightly difference that you can see like because of the COVID-19. So the global energy related CO2 emissions in just 2023 rose by 1.1% or 410 million tons in 2023. So reaching a new high of 37.4 gigatons or 37.4 billion tons in just 2023. So producing or emitting all this gigantic volume of greenhouse gas emissions, what we are doing with our environment, our glaciers are melting, a phenomenon that has been intensified in the 20th century, and that leads our planet iceless. Wildfires, increasing number of wildfires around the world. In just 2023, last year, more than 3.9 million square kilometers of land burned globally. And the major wildfires erupted in the countries in Canada and Greece. Many parts of the world broke the hottest day record, and the climate change is actually contributing in the worldwide land droughts and water shortages around the world. So if we just take a look of the and break down the greenhouse gas emissions in across different sectors, we know the manufacturing sector always contributes the higher amount of greenhouse gas emission than the generation of electricity, growing things, which is the agriculture sector, transportation, and heating and cooling. So we know in manufacturing sector, the main culprits, the main industries are the cement industry and the production of the steel. But these are the giants, the main culprits in which the greenhouse gas emissions emitted most. But after this, the other industry that also contributes a lot in the greenhouse gas emission, that also includes the textile industry. Textile industry is considered as the one of the polluting industries in the whole world. If we just compare the emission across industries of fashion, transportation, and agriculture, we get to know like the fashion industry or textile industry that contributes 10% of the global greenhouse gas emission, that surpasses both aviation and shipping combined. So that's a huge number. And if we compare the water consumption by different sectors, we get to know that textile production consume 20% of the groundwater annually. So the textile industry uses 93 billion cubic meters of water annually, making it a leading water intensive industry. And also keep in mind, nowadays, the growing number of the textile production coming out from the South Asian countries like Bangladesh, Pakistan, India. And in just Bangladesh, they use 1,500 billion liters of water consumed each year, and then they discharge wastewater into the effluent rivers. So all these countries, these South Asian countries, are not just vulnerable to climate change, but they are also water stress countries. So there is a big room of improvement in the textile industry. So why this textile industry is the most polluted industry in this whole world? One of the most polluting industries in the whole world. Most emissions because in this industry is coming out from the production processes, that is the spinning and weaving process, which are the essential processes of this industry. Raw materials, polyester, other synthetic fibers and drive, which are from driving from fossil fuels that emit the greenhouse gas emissions. Textile dyeing is the second largest water uh, polluter globally, and the 92 million tons of greenhouse gas emission waste are generated every year. So the problem is not just the raw material and the extraction processes, all the different operation processes that has been performed in the textile industries, the different mode of energy that has been used in all those processes, that also of the finite resources like fossil fuels and other. If you just take a look of this schematic diagram of the whole production processes in the textile industry, that you can see the fabrication processes, wet processes, yarn and other processes, you get to know in all those processes, the mode of energy that has been used is either electricity that has been getting the industry is getting from the grid electricity, and the electricity is being generated from the coal-fired power plant or the natural gas-fired power plants, again fossil fuels, and the steam which has been generated through the natural gas processes or the natural gas. So all these finite processes. So the as you can see, like the whole the system is so, in best available techniques, the best available techniques after the extensive research that has they have developed to reduce and to transform the most polluting industries in the whole world, and the best available techniques that they focuses on reducing emissions, greenhouse gas emission pollutants, improving energy efficiency, implementing cleaner production practices, and minimizing waste generations. If we talk about the European Commission that mandates the use of BAT in industries and across all sectors, including the textile industries. So all those BAT reference documents in which the European Commission mandate and they suggest and recommend what are the different best available techniques that should be implemented and executed in that particular industries has been published in the website that I have given below. And the other than the textile industry, all those different sectors that has the European Commission mandates to use the best available techniques includes the production of polymer, mining production, sorry, mining production, oil or gas production processes, iron production, etc. So this BAT reference document, it is a very comprehensive document in which the European Commission that mandates the use of different best available techniques. So in the textile reference documents, which is more than 1,000 pages, there are more than 50 best available techniques that are given that should be implemented, recommended by European Commission. So it was not possible to include all those more than 50 best available techniques in this research frameworks. So we have identified the nine. We have identified the nine different best available techniques across three different categories, which is the overall environmental performance, water consumption, and wastewater generation and energy efficiency. So I would also like to share, in the identification process, in the selection process, it is always recommend to consult the stakeholders, managers, and experts. We have already ongoing textile developing project in our lab, and we have a list of stakeholders. But in the meantime, we could not receive all the responses from them. So the selection of all these technologies, we relied on the extensive literature data that are available on the different publishers, and we have selected all these different best available techniques on to them. So in overall environmental performance, if we use use of textile materials containing a minimized content of contaminants, that this criteria includes the use of standard schemes. The use of textile materials with reduced processing needs, that includes the use of synthetic fibers or other different materials. So in wastewater consumption and wastewater generation, water management, plant and water audits, in which the plant and water audits should be carried out each year. Production optimization is the business application, and it is a very effective best available technique in the business application, especially in the dyeing process. water reuse and recycling, and where consideration should be made so that the no other or increased contaminants should be included in the recycled water, in the wastewater, so that that can be recycled. Processing using little or no water, that includes the criteria using the laser treatment. Energy efficiency plan and audits, in which the planned audits energy efficiency should be carried out each year. Use of general energy saving techniques, use of efficient lighting system, use of motor drives, variable drives, and the use of heat recovery techniques, so that in this best available technique, so that the amount of heat should be recovered from the wastewater, so that it can be used in the recycling or cooling process. So this is the overall framework of this research, in which the identification after the identification of best available techniques in the textile industry, we perform the SWOT analysis, which is the strength, weaknesses, opportunities, and threat. And so it is a loop process. So after approval of SWOT, we develop the SWOT-based strategies, and then we use the additional using gray system theory ARAS-G process, which is the multiple criterion decision-making process, and then prioritize strategies of best available techniques in the textile industry. So my results and discussion, in which the SWOT analysis is the structured planning tool used to evaluate the strengths, weaknesses, opportunities, and threats of an organization project. And this is a traditional analytical hierarchy process which helps to prioritize the SWOT factors. So step-by-step process in the SWOT factors is the first we identify what are the SWOT factors, then construct the hierarchy, pairwise distribution, which we use using the triangular fuzzy numbers. Then we compute fuzzy geometric means using this formula, defuzzification of fuzzy values, and then normalize of weights using these equations. So overall, our results of SWOT is the environmental. In strengths, we have the environmental policies, because all the developing or either developed countries, they have the environmental policy. And in strength, the second, our strength is the development of structure for mitigation of waste. So nowadays, a technology like circular economy is being used to for this purpose. The better technology in fiber preparation. So that means like we have the alternate different synthetic fibers technology that we can use in the fiber preparation. So in weakness, the lack of integrated waste management policy. So far, no any policymaker or any lawmaker has been able to draft a very impactful waste management policy. This is one of the weakness. High energy consumed practices that we have seen in our previous slides, like how the different abundant amount of fossil fuel has been used in different textile operations. Inefficient logistics, no any careful consideration should be is usually being made because there is a lack of collaboration in using or selecting the vehicles that has been used in the textile industry. This is one of the weakness. And opportunities, what we have found that the manufactured textile goods. So nowadays, the many developed countries who have resources, they are working on the many fibers which require not so much processing and less processing time. Renewable energy generation, nowadays it is really possible to integrate the electricity that has been acquired from the renewable energy systems, such as the solar, wind, hydro, or something, even nuclear, so that that can be used in the textile industry, because the production of electricity using the renewable energy system is far easier as compared to the acquiring of or the production of the steam or any other gases. So another opportunity is the expansion of new fashion trends. So the new fashion trends, so that has actually expanded the horizon of the textile industry, that requires the less processing times and less needs. And threats, we have the rapid change in the fashion market. The textile industry is already a very complex market. So this rapid change and change in patterns, that further complicates this industry. So lack of corporate response. So far, the corporate response has not been satisfactory so far, and because of this, the public awareness is also not such been great. So the release of hazardous substances that we have already seen in our previous slides, that the textile industry is one of the polluting industries in this whole world, and they release abundant amount of hazardous waste in rivers and in different areas. So if we just take a look of all those criteria score, the weaknesses has the higher criteria score of 0.314, and then there is the second highest score of 0.298. and then 0.218 and 0.17. So first is weakness, then opportunities, strength, and threats. To criteria and calculating of utility degrees for which rankings are placed. So these are the equations that has been formulated from the ARAS-G method. So there are many tools that you can use to apply these equations in your research. I have personally used these spreadsheets, but you can also use the different programming tools like Python, MATLAB, or R language. And there are also different gray numbers softwares are available like Super Decision and other softwares. And nowadays, the MATLAB has a different system tools just assigned for the separate gray number. So there are many, many different tools that you can use to use this ARS-G approach and multiple criteria decision making to have the better decision making techniques. So after using this technique, all the different best available techniques that we have used, we have selected and we rank those. And the first ranking is always the water reuse and recycling. And so this is the ranking list. So after that, we have use of heat recovery techniques, energy efficiency plan and audits, use of textile materials, and so on. So ranking has been scores has been assigned, and then ranking has been placed. So in this way, we are able to determine like what are the different techniques of what we have explored the different criteria. So which techniques should be implemented first on a priority basis. In a conclusion, we have found, I would like to share that water and energy consumption can be reduced by applying best available techniques in the textile industry. And in this industry, implementation should be coupled with energy and water variation because these are the main two major problems in this industry. The methodology for this work may contribute to forming a policy or making decisions for stakeholders and policymakers in this industry. That should be the first criteria. And the sustainable performance of this textile industry relies heavily on business applications as well, just like the ERP, energy resource planning, Internet of Things, blockchains, and other all those different digital and emerging technologies. When all those technology can be implemented in textile industry, that would obviously enhance the performance of textile industry in terms of sustainability. So simultaneously, applications supporting environmental performance such as wastewater management systems and circular economy platforms address the industry's ecological challenges as well. So these are the references that I have used in my presentation. Thank you so much. And I would like to have any feedback, questions, or any suggestion if you have. Thank you.
Thank you, Dr. Farid, for such an engaging presentation on improving energy and environmental performance in textile industry. Now we open the floor to questions from the audience so that we can well deeper into the intricate details of your methodology. If there is any questions from the audiences, please go ahead. I think there is no question from the audience. Well, I have just a quick question. How do you ensure the applicability of your proposed technique in diverse textile industry contexts, particularly with varying levels of technological advancements? Because technologically, digital integration is continuously improving, and every textile industry has different level of implementation of technology. So how do you think it's applicable in those contexts with different textile industries?
Oh, well, thank you so much for the question. Well, it actually depends, but my main area is to address like how this industry is the one of the polluting industries in this whole world, and like the different applications, just like the different emerging technologies or digital technologies that can be applied in the context of sustainability, but their impact would not be as great as compared to the different best available techniques that can be applied to those textile industries. So that the main idea is to reduce the greenhouse gas emission. The main idea is to reduce the energy or carbon footprint. The main idea is to make this industry more sustainable. That can also be done using those different IoT and decentralized system, but that can only be happen when the house has been correct, and how the floor has been open for those different emerging technologies. So that's one of the things that we need to do. And I think we are not so far, because the like after Industry 4.0, Industry 5.0 is already in the corner. So all those different emerging technologies that has been rising from those two different revolutions. So that has been really important to make this industry more sustainable.
Okay, thank you so much for answering my concern. This concludes our lineup of presentation for today's session. Thank you, Anis. Thank you to all our presenters for their thought-provoking presentations today. Each of you has brought a unique perspective on how decision-making processes from customer behavior to environmental performance can be enhanced with advanced methodologies like AHP and AI. And I hope everyone has gained valuable insights from today's session. Special thanks to all the participants for your attention and questions. With that, I officially close this sessions of Industrial Symposium on Analytical Hierarchy Process 2024. Wishing everyone the best for the rest of the conference. Have a great day ahead. Thank you, everyone.